Hi, hello everyone. In today's video, we will discuss about the previous year questions related to electromagnetic theory. So basically, we will discuss the advanced part of the electromagnetic theory, which is related to our vector potentials and to our EM waves in conductor and waveguide. So basically, in today's lecture, we will do PYQ related to topics of EM waves in conductors and waveguide and problems related to gauge transformations and retarded potential. Okay, while solving problem we will also discuss some part of the theory or some concept related to it. Okay, so I have already written the questions today so that our time will be saved. So let's begin. Our first question is, this question has come in JEST 2013. Okay, see, whenever we are preparing for any competitive exam, whether it is IIT JAM or we are preparing for CSIR net or for any other MSc entrance exam, it is always useful to solve PYQs of different exams. If you are preparing for IIT JAM, then also solve PYQs of DU entrance exam, BHU entrance exam, set exams like Gujarat set, West Bengal set, Maharashtra set. Different states have their exams. You can solve those papers. It will be very helpful because from there we can also understand that how the questions are getting framed, and also you can get common from these papers. You can get common for these papers. If you are preparing for set examination, then I have seen that some questions are directly coming from CSI net exam. Directly same to same question you can get. If you practice these papers and if you are giving set examination, you will get approximately 4 to 5 questions common. So whatever exam you are giving, solve all the PYQs of different examinations related to this physics. Okay, you can also solve some questions of TFR also, which are the simpler ones, not the so tougher ones if you are preparing for IIT JAM. Okay, okay. So the question says that if the conductivity sigma of a metal is 10 to the power 6 ohm meter inverse and the dielectric constant value is given as this time, the time will be approximately, not this, the time will be approximately in seconds. You have to find this. Okay, so how to solve this question? So first we will read some of the theory part, the concept behind this question. Okay, now we know our famous continuity equation. What does it say? It says that del dot j plus del rho del t equals to 0. Correct? Where j is what? I hope you know what are these terms. Del is the operator, that is I cap del x plus j cap del y plus k cap del z. Okay, and j is what? J is our current density. Okay, and rho is what? Our charge density. It is charge per unit volume. Okay, now we also know J is equal to sigma E, where sigma is the conductivity and E is the electric field intensity. This is our Ohm's law. This we get from our Ohm's law. Now if we substitute this value, what will we get? Del dot sigma E plus del rho del T equals to 0. Sigma is constant, we can take it outside. Del dot E plus del rho del T equals to 0. Right? Okay. Now also from Gauss law we know what? Del dot E is equals to rho by epsilon naught. Correct? So we will substitute this. So we will get sigma rho by epsilon naught del rho del T equal to 0. Okay. Now del rho del T, that is equals to minus sigma rho by epsilon naught del rho by rho, that is equals to minus sigma by epsilon naught del T. Here no other constant, no other variables we are getting, right? These terms are constant. So we can convert this into d rho minus sigma by epsilon naught dt. So if we integrate now, what we will get? ln rho is equals to minus sigma t by epsilon naught plus ln rho 0, where rho 0 is a constant of integration. Okay, now we will get what? Rho is equals to rho 0 e to the minus sigma t by epsilon naught. So we are getting this equation. Okay, okay, then now this is epsilon naught for vacuum, that is free space. Okay, now if it was medium, what we would get? This would be for a medium, correct? Okay, now let's go back to the question. Value of sigma conductivity is given, value of epsilon naught is given. We need to find the value of time. Okay, so now since it is given for a metal, and we know what metal is a conductor, and we know for a conductor at equilibrium there is no charge inside, right? There is no charge inside. If there is no charge, then will there be any charge density? No. Then rho is equals to 0. Very good. Then we will get what? Rho 0 e to the minus sigma t by epsilon is equals to 0, which concludes what? E to the minus sigma t by epsilon equals to 0. That is sigma t by epsilon equals to 1. So t is equals to what? Epsilon by sigma. So this is the formula we are getting, which is useful for us in this question. Now we will substitute this value. T is equal to here sigma naught by epsilon, because they are given in free space. Value is given 8.854 into 10 to the minus 12, and sigma value, that is the conductivity value is given what? It is given 10 to the 6. Okay, we will substitute this value. So this is what? 8.854 into 10 to the power minus 12. This 6 will come in the numerator and we will get minus 6. Okay, let's see the options now. So options, they have only given in the order of 10 to the power. Okay, so let's see this, what we are getting. We are getting this 8.854 into 10 to the power 12 minus 6, that is minus 18. This can be approximately written as 10. So we will go 10 to the minus 17 approx. In question also they have asked in approx what will be the answer. Okay, so our answer is what? Option D is the answer. 10 to the power minus 17. So we understood this. Okay, you understood the theory part, how we are getting this formula, how we got this, you understood, and then just we have to substitute the value and nothing else. Okay, so this question we understood. Now we will proceed to our next question. Okay, question number 2, I have already written today all the questions. Question number 2 is what? A uniform charge density is placed inside a conductor with resistivity 10 to the power minus 2. Okay, now this time they have given what? Resistivity. Okay, the charge density becomes 1 by 2.718 of its original value. After time, we need to find the time. We will use that same equation which we have derived. We have already derived this, right? We will use this equation now. Okay, now they have said the charge density become 1.1 by 2.718 of its original value. This was its original value. This was rho 0 is the value of charge density at time t equals to 0. Okay, because if you substitute that time t equals to 0, you will get rho is equals to rho 0. This term will be 1. Okay, so this rho is saying rho 0 by 2.718. It is given. That is equals to rho 0 e to the minus t sigma by epsilon. This will cancel out. Okay, let's see what we are getting. So this is 1 by 2.718. It is equals to e to the minus t sigma by epsilon. Okay, do you know what is this? What is this? This is 1 by e. Okay, so e to the minus 1 is equals to e to the minus t sigma by epsilon naught. So we will get t sigma by epsilon, it is equals to 1, or again we will get t is equal to epsilon by sigma. This also we have derived. Right, now resistivity is given and epsilon value is given. Okay, now t is equals to epsilon by conductivity. Now resistivity is equals to 1 by conductivity, reciprocal of conductivity. So it will be epsilon naught in free space into resistivity. Don't confuse with charge density. Okay, this is resistivity. Okay, so epsilon is given what, 8.4 into 10 to the minus 12, and resistivity value is given what, resistivity they have given 10 to the minus 2. Okay, so this is 10 to the minus 2. So what we are getting, 8.854 into 10 to the minus 14. The answer they have asked in femtoseconds. Now femtoseconds means 10 to the minus 15 seconds. Okay, so if we convert this into 10 to the minus 15, this will be 88.54. So our answer is what, this is our answer. 10 to the minus 15 they have already said, femtoseconds they have mentioned. We need to find this value. So this value is what, 88.54 femtoseconds. Okay, I hope you understood this. Okay, now we will proceed to our third question. Okay, so third question is what, a monochromatic plane wave in free space with dielectric field amplitude of 1 volt per meter, okay, is normally incident on a fully reflecting mirror. Okay, pressure exerted on the mirror is, okay, now for fully reflecting mirror, for fully reflecting mirror, we know P is equals to what, 2I by C. If in question they have not mentioned the term fully reflecting mirror, then the formula for pressure will be, if not fully reflecting mirror, then pressure is equals to I by C. Okay, since it is fully reflecting mirror, there will be a term 2, twice of I by C. Okay, okay. So let's do now. P is equals to 2I by C. I, that is the intensity. Intensity, this value we can get from where? From Poynting vector. From Poynting vector we can get the value of intensity. We know what is Poynting vector. It is denoted with S, that is equals to 1 by mu naught E cross B. The theory part I will explain in detail. I will take a theory class and then I will explain in detail that what is Poynting vector, what is its significance. Okay, right now we need to know the value of this formula of intensity, that is what, I is equals to half C epsilon naught E naught square. You can get from this also, we know some values, like we know C, that is speed of light, that is equals to 1 by root mu naught epsilon naught, right? Again we know that B, it can be written as what? B can be expressed in E. How? B is equals to Ke by omega square. Right? Now if we substitute all these values, we will get the value of intensity. Okay? We will get the value of intensity. Again, we can also write B as what? E by C. If we substitute this value here, then we will get the term related to E. Matlab we will eliminate B. Okay. Now intensity is what? Basically the average Poynting vector. So we will get this value, that is half C epsilon naught E naught square. Okay. You can substitute these values, both the values, and you will get this only. So we will use the formula, that is 2 into half C epsilon naught E naught square by C. So this will cancel out and we will get epsilon naught E naught square. Okay. Now epsilon naught value we know, 8.854 into 10 to the minus 12, and E naught they have already mentioned, it is 1 volt per meter. Okay. 1 square is 1 only. So we are getting what, 8.4 into 10 to the minus 12. Now let's see in what unit they have asked. Okay. They have asked in the unit of 10 to the minus 12. They have asked in the unit of 10 to the minus 12 Pascal. Okay. So what we are getting? Our answer is what? 8.854 into 10 to the minus 12. So this is our answer. This is already given. So our answer is what? 8.854. So I hope you understood this question. I hope you understood this. Okay. Now let's proceed to our next question. So our next question says that skin depth of a metal is dependent on the conductivity sigma of the metal. and the angular frequency omega of the incident field. For a metal of high conductivity, which of the following relation is correct? Okay, before that we need to know what is skin depth, right? Skin depth is what? It is a distance, it is that distance below the surface of a conductor. It is that distance below the surface of the conductor, below the surface of the conductor, where the current density, has decreased to 1 by e of its initial value, that is of its value at the surface. Okay, so this is our skin depth. Now skin depth is actually denoted with delta. Okay, and that is equals to 1 by kappa minus. Okay, kappa minus and kappa plus, this term comes due to the imaginary term present in our electric field. Okay, I will discuss in the theory part, and if you have any problem regarding this, or if you are not getting what is this kappa or any theory part related to the topics or the formulas I have discussed, you let me know in my Telegram channel. If you have problem, I will make a theory video. Okay, so basic theory which is needed for solving a question, I am explaining those. Okay, you need to know how to solve a question. We know a lot of formulas, we know a lot of theory, but we sometimes don't know where to use this. Okay, so that is very important. Ultimate, at the end of the day, you have to solve problems, right? Okay, now 1 by kappa minus. What is kappa minus? The formula of kappa minus is omega. This we are getting after solving differential equation. In terms of E, also we get in terms of B, but this we get by solving the differential equation, wave differential equations in terms of electric field E. Okay, so the value, at the end we get this value. This we get. Now this value is little bit manipulated when they ask for metals and when they ask for insulator. Now for metals, obviously we know the conductivity for metal is much greater than what? Omega epsilon. With this product, the value of sigma, that is the conductivity, is much greater. In insulator, just the opposite thing happen. For insulator, we get this value. Right, now we will derive the expression for both metals and insulator. Okay, okay, so let's start with metal. Since we know that sigma is much greater than omega and epsilon, where omega is the angular frequency and epsilon is the permittivity of the medium or of the free space, whatever mentioned in the question. Now kappa minus, for this case, that is for metal, this can be written as the omega mu epsilon by 2. Now here, if sigma is much greater than omega epsilon square, so I can say what? 1 plus this term is nothing but, I can write this as sigma by omega epsilon square. I can eliminate this 1 from here, right? Because if sigma is much greater than omega epsilon, so this value is ultimate a larger value, and if 1 is increased, 1 is added to a larger value, that means we are getting that larger value. No major change we will get. If you add 10,000 plus 1, so there is no major change, right? So this can be written as sigma by omega epsilon. Okay, now next we will again solve this. Omega root mu epsilon by 2. Now square and root, so we will get the same term. Again from a very large number, if you subtract 1, there will be no major change and we will get that same quantity again. So we will get here sigma by omega epsilon. Right, now this omega will cancel out and we will get mu epsilon by 2 sigma by epsilon. Now this will result to mu, this sigma is here, so this will be 2 sigma, 2 epsilon, and sigma we will get outside. So here we have got, okay, so there is 1 by half over here. So if we do this, what we are getting, this will get cancelled out, so we will get mu sigma by 2. Okay, and there will be an omega here. This omega will not be cancelled out. This will be here omega and this omega. So ultimately we will get this. Okay, so this is for metal. This is the value of kappa minus. So skin depth, which is denoted with delta, so that is equals to 1 by kappa minus, that is equals to root 2 by mu sigma omega. Okay, now we will find for insulator. So for insulator, you see our sigma is much less than omega epsilon. So we have to do binomial expansion then. So our term is what? Omega root mu epsilon by 2. This will be as it is. This we will do binomial expansion. So if we do binomial expansion of this and neglecting the higher order terms, we will get omega epsilon. Okay, this, I hope you understood this. This is coming how you see. This is 1 plus sigma by omega epsilon square half, right? Now if we expand this, this half will come here, 1 plus nx, this formula. So this we will get. Okay, again we will get some higher order terms, but we are neglecting this. So we are getting here omega root mu epsilon by 2. This one and this one will cancel out. We will get half epsilon omega 1 by 2. So what we are getting, what term is getting, and this half and this half will be 2 omega by 2. This will cancel out. So we will get mu sigma by omega. So we are getting this half mu sigma omega. Okay, so we are getting this. So skin depth here is 1 by kappa minus. So we are getting this 2 by root mu sigma omega. So this is the skin depth value for insulator and this is the skin depth value for metal. So in question they have asked for metal only. Okay, so where is the question? They have asked, they have denoted skin depth with D. Okay, so let's see, skin depth is proportional to what? Here in question delta is D. Okay, so it is proportional to root over 1 by mu sigma omega. Now here they have asked dependency on what? Here they have asked dependency on sigma and omega. Okay, okay. So sigma and omega. So D is proportional to root 1 by sigma and omega. So which option is correct? Let's see. 1 by sigma omega. Okay. So this option B. So our right option is option B. Okay. Rest options are wrong. So this is our right option. Okay. So I hope you understood what is skin depth, how to find the value of skin depth for metal and insulator. Okay. Try to remember these formulas. It will save your time. Okay, so let's proceed to the next question. Okay, this is the question which is related to waveguide. Okay, this is saying what? The magnetic field of the TE11 mode of a TE11 mode means transverse electric. Okay, so there are two types. One is transverse electric and another is what? Transverse magnetic. Okay, so of a rectangular waveguide of dimension A cross B is given by, if you don't know the theory portion of this, you let me know. I will give a theory class regarding this waveguide. Okay, so they have given of dimension A cross B is given by Hz is equals to H1 cos 0.3 pi x cos 0.4 pi y. Okay, so the general formula of this is what? Hz is equals to, general formula is H1 cos n pi x by A cos n pi y by B. This is the general formula. So if we now evaluate this 2, then we will get the values of n pi x by A is equals to 0.3 pi x. So what we are getting, see here, n is equals to 1 because see it is TE11 mode and this is m. Okay, so from here n is equals to 1 and m is equals to 1. Basically TENM mode. Okay, we write this in this way, TENM mode. Okay, so T and M mode, so it is 1 1, that means N value is 1, M value is 1. So from here, if we put N is equals to 1, so we are getting what? A is equals to 10 by 3, right? Okay, so again M pi Y by B, in the question they have given 0.4 pi Y, M value is 1, so 1 pi Y by B, that is equals to 0.4 pi Y. Okay, so from here if we see, we are getting Y is equals to 10 by 4. So this is approximately 3.3 and 10 by 4 is 2.5. So let's see which answer is correct, which option is correct. We are getting 3.33 and 2.5. So this option is correct, option A. Okay, so it's so easy. So this option is correct, option A. It was a very easy question. This is net question. The two parts of it. There's the first part we have done. Now second part is what? The entire range of frequency f. Okay. So first we need to know the formula of frequency f. Okay. So for TE mode, here 1 1, frequency f must be greater than c by 2. C is the speed of light. M by A. A and B are the dimension of the rectangular waveguide. Okay. If this is the rectangular waveguide, then A and B is the dimension. Okay, this is A and this is B. Okay, now F must be greater than C by 2. Now M and N both are 1 1. See this, M and N are 1 1. A and B we have calculated. This is 3.33 centimeter and this is 2.5 centimeter. Okay, so better if we write this in terms of 10 by. So this is what basically, this is here there is square, so this is basically 3 by 10 and this is 4 by 10 square, correct? Yeah, M by A square, right? So we got A as 10 by 3. Yeah, okay. So if we calculate this, what we will get? This 10 square and 10 square, this 10 will come outside, 1 by 10 and 3 square plus 4 square. So f is greater than c by 2 into 1 by 10, this is equals to 5. So we are getting f is greater than c by 4. Okay. So f is c by 4. 3 into 10 to the power 8 by 4. Okay. So that is f is greater than, if I take this 30 into 10 to the power 7, I can write in this way, right? So 30 by 4, that is equal approximately 7.5 into 10 to the power 7 hertz. Okay. So now the answer is in gigahertz. Okay. So the answer f must be greater than. Okay. So the answer is in gigahertz. So we know what 1 gigahertz is equals to 10 to the power 9 hertz. Okay. So now, okay, so this was all in centimeter. The value we have substituted is in centimeter. So this will be, here we will get into 10 to the power 2. Okay, so this one will be 9. So f is greater than 7.5 gigahertz. Okay, now let's see this option. Which option is correct? F is greater than 7.5 gigahertz. Option D. So correct option is option D. So I hope you understood. This type of questions can come from waveguide. Okay. This was NET June 2011 question. Okay. So now let's proceed to the next question. That is question number 6. This is also waveguide question. So if you will do questions now, your theory will be also clear and you will get the confidence how to solve questions in the examination hall. Okay, now let's see what does it say. It says that let us consider a rectangular waveguide with transverse dimensions. They have given the dimension 2 meter cross 1 meter, driven with an angular frequency omega. Which transverse electric mode will propagate in this waveguide? For propagating, we know our frequency. This frequency, the value of frequency f must be greater than c by 2 root m by a whole square plus n by b whole square. Here they have asked for omega. So we know if I multiply it with 2 pi f, we will get omega. So here also we have to multiply with 2 pi. So we will get omega must be greater than pi c root m by a square plus n by b square. Okay. So here the dimension of A and B are given. A and B they have given 2 cross 1. Both dimensions are in meter. Okay. So pi c. Now m by A, that is 2 square plus n square. B is 1. Okay. So now we have to see such values of omega by substituting the values of this m and n, that omega must be greater than pi c and this calculated value. So we will go with options. Okay. Now you see in the exam you will get this 4 options and each option has got 3 terms. So if you calculate, so it will be a little tough. So you have to use your brain. Now you see here, one thing we can see that TE10 is common. See, TE10 is common in all. So we will not check TE10. This is the common. So next you see TE20 we are getting here and TE20 we are getting here. Okay. So we will calculate TE20, we will calculate TE11 and TE01. First we will calculate this three. We will get an idea. So let's go with this. So first we will do TE20. Okay, this is m value and this is n value. So omega must be greater than pi c. M is 2 by 2 square. N is 0. Okay. So omega must be greater than pi c. 2 by 2, that is 1. So omega must be greater than pi c. They have said omega is equals to 10 to the power 9. Omega is equals to 10 to the power 9. Is this greater than pi c? Pi is what? 3.14 into 3 into 10 to the power 8. So 3 and 3.14, that is 9. No, this value is more. So omega is not greater than. So this is wrong. So T20 is not acceptable. So options where T20 there, this option is wrong. This option is wrong. So cancelled. So you understood how you have to proceed the question. First analyze the option. Analyzing options are very important. Okay, this is also a PYQ question. Okay, wait, let me check. This is which year question? This is net June 2015 question. This is net June 2015 question. Okay. Now we will find two other terms. Okay. Now we will find two other terms. Okay. Omega must be greater than pi c. Okay. So this is 3 into 3.14. Okay, wait, we have done some mistake here. Wait. This is basically we are getting 9.14 into 10 to the power 8. Okay, so 9.14 into 10 to the power 8, this value is less than 10 to the power 9. So this is possible. Sorry, we did one calculation mistake. So this is possible. Right, 9.14 10 to the power 8 is obviously less than 10 to the power 9. So this is possible. So the options which we have said wrong, so these are not wrong. This can be an possible options. Okay. So this can be possible. The T20 can be possible. Okay. Now to eliminate, we have to see those terms which is common. See, C and D both have T10, but A and B does not have T10. So if we find the T10, if we see that T10 is not applicable, that the value of omega is not greater, then we can simply eliminate these two options. So find T10 now. Okay, TE10. For this omega must be greater than pi c root. Here we are getting what? 1 by 2 square plus again here 0. So omega is greater than pi c. So this is 2. Okay, pi is 3.14 into 3 into 10 to the power 8 by 2. So this is what? This is again omega is greater here. So this is also possible. So now T01 we did, this is also possible. Okay, so left is what? T11, T22. Okay, so if we find T11, these two options can be cancelled. So let us find T11 now. TE11. For this omega must be greater than here 1 pi c 1 by 2 square plus 1 square. So what we are getting here? 1 by 4 plus 1, that is root 5 by 2. Okay, So root 5 by 2, if we calculate this, we will get uh, root 5 by 2. If we calculate, we are getting 1.11. Okay. So pi c into 1.12. Okay. So this is 10 to the power 9 and this is 3.14 into 3 into 1.12 into 10 to the power 8. So here omega is obviously not greater than this. So this option is wrong. So T11 is not possible. Okay, so now let's eliminate some options here. T11. Okay, so what we are getting? T11 is where? Okay, see. So this option is not possible. This is not possible. T11, this is not possible. Okay, so now this is possible or this is possible. Now T10 we have checked, T20 we have checked. Now we have to check either T01 or T22. See, this calculation is easy. There is already one zero present. So let us go with T01 first. Okay, T01. So for this omega must be greater than pi c root, this is 0 plus 1. So omega must be greater than pi c. So omega is greater than pi c. This we know. So this option is correct. So we will not check T22 now. Because this is not MSQ, this is MCQ. So one option will be right. So our correct option is which one? A. So our correct option is A. Okay. So you understood how you have to check. Okay. Okay. So now next proceed to the next question. Okay. So this is what? This is TFI question. This is consider a dipole antenna with length L, charge Q and frequency omega. The power emitted by antenna at a large. So this is basically a theory question. Okay, so now suppose the length L is increased to root 2 L, the charge is increased to root 3 Q, L is increased to root 2 L. Okay, the frequency is increased. Actually, this question is written double. Frequency is increased to root 5 omega. Okay, so by what factor is the radiated power increase? Now you know the formula for radiated power P is equals to what? P naught square, not formula, it is proportional to P naught square omega to the power 4. P naught is the dipole moment, that is we know Q into distance D. Okay, this is the dipole moment of opposite charges and this is the separation distance D. So dipole moment can be written as QD. Okay, so the power P is proportional to Q square D square omega to the power 4. Now if P1 is equals to, suppose is the proportionality constant K. So now second case P2, here they have said what is changing, length is changing to root 2L. Okay, so length is changing to root 2L. So this is K, our D is root 2L. So suppose this is here D is L. Okay, so okay, wait me now rub this into L only. So there will be no problem. This is L. Okay, this is also L. So this is L, this is L square, this is L square, this is root 2 L square. Okay, now charge is increased by what? Charge is increased by root 3Q and frequency is increased by root 5 omega. Okay, so charge is increased by root 3Q and omega root 5 omega to the power 4. Okay, so K 2L square, 3Q square and this is 25 omega to the power 4. So we are getting K Q square omega 2 to the power 4. L square is also there and here 2 3 is 6, 6 into 25, that is 150. Okay, so this is what? P1 150. So P2 is what? 150 times P1. So by what factor is the radiated power increased? So the factor is what? Factor is 150. So this by this factor, by 150 factor the radiated power is increased. Okay, this simple question. This formula is very important. Remember this formula. Okay. Okay, so now next let's proceed to the next question. What they have said, if the vector potential A satisfies the Coulomb gauge, the value of the constant alpha is. Okay, so you need to know that for Coulomb gauge the condition is what? Del dot A equals to 0. Okay, just now we have to do the calculation. Dot A is what? Alpha x. Here x cap means I cap. Okay, Here x cap means I cap. So alpha x I cap plus 2y j cap minus 3z k cap. So this is what we are getting, I cap because rest term will be 0, right? So del x of alpha x, that is alpha, del y of 2y, that is 2, and del z of minus 3z, so this is minus of 3, that is equals to 0. So we are getting alpha minus 1 equals to 0. So we are getting alpha equals to 1. Okay, so this is so easy. Just we have to know the concept is what, for Coulomb gauge del dot A equals to 0. Okay.